With their virtualization infrastructure in place, Woodgrove Bank has found that they can realize significant savings through a combination of energy conservation, improved workflow, and streamlined deployment. Organizations of all sizes are focused on cutting costs by increasing the efficiency of their computing resources. Virtualization is a standard green IT technique, and server virtualization allows multiple operating systems to run on a single physical machine as virtual machines, consolidating workloads across multiple underutilized servers. Building a hypergreen virtualization server system is focused on taking the extra steps necessary to further reduce energy consumption. Here are 7 steps you can follow, and their estimated savings in building a hypergreen server virtualization system. Step 1. Know your server loads. To get a realistic picture on their energy consumption and savings, Woodgrove Bank needs to determine their own loads and evaluate a strategy based on those conditions. Using virtual machines, development staff at Woodgrove Bank can create and test a wide variety of scenarios in a safe, self-contained environment that accurately approximates the operation of physical servers and clients. The Microsoft Assessment and Planning Toolkit, or MAP, makes it easy for Woodgrove Bank IT staff to assess their current IT infrastructure and determine the right Microsoft technologies for their IT needs. Over the long run, Woodgrove Bank could make a difference of 20% in performance per watt by understanding their server loads up front, measuring how their SLAs are met, and planning their migration based on this knowledge. Step 2. Plan for high utilization. With virtualization server consolidation, component constraints can become an issue. Woodgrove must evaluate whether they have enough RAM to run a VM without overly taxing the disk, and must question whether they have enough storage to accommodate the VMs and required backups. To meet maintenance and performance requirements, one option is to create dedicated server roles. For example, they could create a virtualized SharePoint servers category, which would simplify maintenance and security and would allow them to fine-tune performance on that platform without having to consider any other application types. If they do run into performance problems, they'll know that it's not due to one server role affecting the performance of another. Performance and Resource Optimization, or PRO, is a feature of Virtual Machine Manager. It helps ensure that the virtual machine infrastructure is operating in an ideal and efficient manner. PRO uses rules and policies set by an administrator to dynamically respond to poor performance and failures of virtualized hardware, operating systems, and applications. By pushing harder and operating their system at a higher utilization level, Woodgrove can save approximately 10% of their energy consumption. Step 3. Save power. Power management is essential for laptop computers, and it's now standard on server processors. Microsoft Windows Server 2008 R2 provides new features for saving more power. R2 features power metering and budgeting in conjunction with hardware support, which helps provide the tools you need to set energy consumption goals, measure your progress against those goals, and save power throughout your environment. Every hardware component has a power footprint. RAM power consumption is second only to processors, especially when you consider the amount of DIMMs and memory required for VM solutions. Woodgrove Bank has estimated that they can achieve a 10% power savings by using power management. They can also disable the BIOS-based power management and use the operating system power management to maximize savings. Step 4. Eliminate waste. Windows Server 2008 features a Server Core installation option. Server Core offers a minimal environment for hosting a select set of server roles, including Hyper-V. It features a smaller disk requirement, memory profile, and attack surface. Minimizing the background activity in idle VMs releases CPU cycles that can be used elsewhere by other VMs or saved to reduce power consumption. And if Woodgrove Bank decides to go for that last ounce of performance, they could configure their VMs to a non-uniform access or NUMA node. You can read more about this by searching for the term NUMA node on the Microsoft website. In this area, Woodgrove Bank can expect about 5% savings. Step 5. Identify your Hyper-V SKUs. The hardware considerations for Hyper-V servers generally resemble that of other Windows server-based servers, but Hyper-V servers can exhibit increased CPU usage, consume more memory, and need more I/O bandwidth. Performance per watt should be the new focus for Woodgrove Bank as they consolidate servers, not just CPU metrics. They should size VM memory as they typically do for server applications on a physical machine. They must have sufficient memory to handle the expected load at ordinary and peak times because insufficient memory can significantly increase response times and CPU or I/O usage. For best CPU performance, there should be one virtual processor per logical processor core. Hyper-V supports synthetic and emulated storage devices in VMs, but the synthetic devices generally offer significantly better throughput and response times and reduced CPU overhead. The storage hardware should have sufficient I/O bandwidth and capacity to meet current and future needs of the VMs that the physical server hosts. If the Woodgrove Bank IT staff expects network-intensive loads, the virtualization server can benefit from having multiple network adapters or multi-port network adapters. Matching their virtualization SKUs to server load is one of the most important decisions for Woodgrove Bank to make. Because matching SKUs to server load has a broad effect on many different areas, this presents as much as 25% of their savings opportunity. Step 6. Plan, Deploy, Monitor. Microsoft Visio has released planning tools for configuring racks for virtualization and then monitoring your cooling system in your server area. Note that the amount of power required for cooling servers can be as much as 100 to 200% the amount of energy used to run the servers. Monitoring is even more critical than usual because when servers are used to capacity, they generate more heat and put more stress on the cooling system. The Microsoft Virtualization site can help Woodgrove quantify and report their virtualization project. The site provides a tool that reports their energy savings for servers and cooling and provides additional reporting on carbon emissions. Accurate planning and careful rollout should require 20% of their effort and provides the second greatest opportunity for savings after defining Hyper-V SKUs. Step 7. See the forest, not the trees. So how does Woodgrove Bank know that they're achieving hyper-green performance per watt? If they use a synthetic driver rather than an emulated driver, they'll be more efficient because they'll use fewer processor cycles and get higher performance. Power summarizes the energy used by all components in a server and gives an overall indicator of how hard the server is working. It's hard to gain perspective about when to act and when to wait for information, but being willing to take action is just as important as using power management. While it's hard to quantify, they'll likely get 10% gain by being an early adopter. While the IT staff at Woodgrove Bank may not be able to complete all of the tasks in this list, even if they complete a few of them, they'll be on a better path. Over half of their savings will come from understanding their loads, good planning, and making sure that they're solving the right problems. Every step should fit in their overall plan. The results can be modified to support their scenario. After all, their scenario differs from everyone else's, and the only way that they can be a hyper-green performer is by developing a plan for their own needs.